Hello and welcome to another video for pre-calculus. Starting this video, we are going to look at trigonometry part of the pre-calculus. So the first section that we are going to discuss here is the angle measure. So let's start with the definition of an angle. So an angle is formed when two rays intersect at a common endpoint. So for example, here we have these two rays and they intersect at the common endpoint. So this is an angle. So that's how the angle is formed. So we will have one fixed side, which is called the initial side. So this, let's say this is the initial side of this angle, and this common point is called the vertex, and the other side is called the terminal side. So the terminal side is the one. So for example, at the beginning we have both terminal and initial side along this line, for example, over here. And then if we rotate that terminal side and then stop somewhere else, so we rotate in the let's say counterclockwise direction, and then we stop here. Now the angle is formed. Okay, and we can denote this angle by any letters. So usually we use Greek letter theta or beta or alpha, any of those symbols to denote the angle. So now we could have positive or negative angle. So if we form the angle by rotating this terminal side in the counterclockwise direction, then we make a positive angle. So we'll have a positive angle if we form the angle in counterclockwise direction. And then we could have a negative angle, or angle is measured as negative angle if it is, for example, this is the initial side, and if we rotate in this direction and then we make an angle here, so this is a negative angle. So we will have a negative angle if we rotate that ray in clockwise direction to make the angle. So if we rotate in clockwise, or if we measure it from the clockwise direction, then the angle is a negative angle. So there are different types of angles. So the first one, acute angle. An angle is acute angle if it is between 0 and 90 degrees. So let's say theta is an angle. So if it is between 0 degree and 90 degree, okay, so then it is called an acute angle. So the other angle is obtuse angle. So if an angle is greater than 90 degree, okay, so it is greater than 90 degrees and then less than 180 degrees, then that angle is called the obtuse angle. Then we have a reflex angle. Reflex angle is the angle which is greater than 180 degrees and then less than 360 degrees. And then we have right angle. Right angle is the angle which is exactly 90 degrees. And then we have another angle which is straight angle. Straight angle if it is exactly 180 degrees. And then we have, we call two angles as complementary angle. So complementary angles if their sum is 90 degrees. So for example, we have angle theta and then angle beta. Okay, so when you add them, if we get 90 degrees, then these are called the complementary angles. Similarly, if we have a supplementary angle, so two angles are called supplementary angles if their sum is 180 degrees. Okay, and then we have different units to measure angle. We'll discuss about them, the other units later. The common one that we know so far is degrees. So we measure angle in degrees. There are other ways to measure them. We'll talk about that. The first one is degree, and then we have a symbol. So for example, if we say 30 degrees, then we write 30, and then we write that symbol degrees. And it's very important that we put that symbol, then only we'll understand it's an angle. So we have these subunits or smaller units for degrees. Just like in time, we have hour, minute, and second. Similarly, when we measure an angle in degrees, we have these subunits, the smaller units, which is degree. Then we have minute and second. So minute which is denoted by 1 uh, like prime, okay, and then we have seconds. So for example, if I have an angle 27 degree, 30 minutes, and let's say 21 seconds, that's how I write it. And we can change all of this into degrees and we'll get decimals. So if we divide 30 by 60, then that changes to degrees. If we divide 21 by 60, that will change to minute. And then if we divide by another 60 or 3600, then it will change to degrees. So, and then in calculator, you have that function where you can put angles in minutes and seconds, or you can change them to um, decimal degrees, okay? So this is the basic introduction of what angle is. The trigonometry, the whole thing trigonometry, when we talk about trigonometry, it is the study of the relations between the sides and angles in a triangle. And then we'll extend that into a function of angles and function of real numbers later. But that's the basic idea, is the study of relations between angles and sides in a triangle, okay? So now we know what angle means, different types of angles that we have, how we measure angle. Now, usually in this course, we'll talk more about functions, trigonometric functions, and then when we do that, we usually place angle in certain position. So an angle is in standard position if the vertex is at origin, okay, and the initial side, remember we have initial and terminal side for the angle. So the initial side is along the positive x-axis, and then if we make an angle, so for example, let's say this angle, so now I say this angle theta is in the standard position because the vertex is at the origin and the initial side is along the x-axis, okay, positive x-axis. Now the angles in the standard position having their terminal sides along the x-axis or y-axis are called quadrantal angles. So this is 0 degree, okay. Now this is 90 degree, so this is a quadrantal angle because that's the angle that is along the y-axis. Now if we go over here, now this is 180 degrees, so it's a straight angle and it's a quadrantal angle. And 270 degrees is also a quadrantal angle because it is along the negative y-axis, and then comes back here 360 degrees, and then we can keep going around, okay. So angle is not just from 0 to 360, we could have as big as you can think, we could have that angle. What we do is once we get here 360, then we go around, and then we can make 360 plus 180, that's another angle, so bigger than 360 angles. Or we can also go on the opposite direction and we can make some negative angles as well. So angle, it goes from negative infinity to positive infinity, so we can keep going around, okay. So now that leads us to another terminology, which is the coterminal angle. So for example, if I have an angle which is, let's say, 60 degrees here. Now 60 degrees formed like this. If I go from this initial position or initial side to this terminal side, that's 60 degrees. Now, if I keep going and if I go around and come back here, so I went 360 degrees around. So 60, I have the 60 initially. And then when I went through another full revolution or 360 degrees, then I get 420 degrees. So this angle is again the same angle with the same terminal side here. So now 60 degrees and 420 degrees are called coterminal angles because they have the same terminal side, okay, common terminal side. And also not just that way, I can go in the negative direction, okay, I can go around this one, and then I'll have another negative angle, which is 300, negative 300 degrees, and then that also gives us the coterminal angle for 60 degrees, okay. So coterminal angles mean the angle with the same terminal side, and we can generate as many as we want. You can keep going on infinite number of loops, and you can keep generating coterminal angles. Now, the simple way of finding coterminal angles is you add 360. You can keep adding 360 to generate more and more. Or if you want the negative, then you could keep subtracting 360 degrees again and again to get more coterminal angles. So for example, the first example we have here, it says find two positive and two negative coterminal angles with 125 degrees. So if we do 125 degrees plus 360 degrees, that is going one full rotation in positive direction. So that gives us 485 degrees, and that is a coterminal angle with 125 degrees. Now, if I add another 360 to 450 degrees, or if I add 720 degrees to 125, whichever you do, so you can say 485 degrees plus another 360 degrees, then we get 845 degrees, which is also the coterminal angle with 125 degrees. Similarly, to find the negative coterminal angle, we can do 125 degrees minus 360 degrees, and that gives us negative 235 degrees, and that's the coterminal with 125 degrees. And then we can do negative 235 degrees minus another 360 degrees. That means basically you are going another round in the opposite direction or the negative direction, and then you generate another angle which is negative 595 degrees. So all of these angles are coterminal angles. Now this one says find the smallest positive angle coterminal with this one. So smallest positive angle that is coterminal with the given angle should be between 0 degree and 360 degree, because those are the positive angle that we generate in one revolution. Okay, so in order to find that, if you have a positive angle and then you are trying to find a coterminal angle that is the smallest positive coterminal angle that is between 0 and 360 degrees, what we do is we keep subtracting 360 degrees until we get an angle between 0 and 360. So that gives us the smallest positive angle. That is coterminal with the given angle, okay? But if you have a negative angle, then we keep adding 360 until we get a positive number between 0 and 360. So for example, we have 870 degrees here. So if we subtract 360 degrees, okay, so when we subtract 360 degrees from 870 degrees, we get 410 degrees. This is also a coterminal angle with 870 degrees, but it's not the smallest positive, because for it to be smallest positive, it has to be between 0 and 360 degrees. So what we can do is we can go ahead and subtract again 360 from here, and that gives us 50 degrees. So this is the smallest positive angle that is coterminal with 870 degrees. Now if you subtract 360 again, that will take us to the negative angle. Still it's a coterminal angle, but it's not the smallest positive, okay? So similarly here, with the negative 35 degree, we are trying to find the smallest positive coterminal angle. So we'll just go ahead and add 360. And then when we do that, we get 325 degrees. And this is the smallest positive coterminal angle with negative 35 degrees. Because if we add 360 again, that will exceed 360. It will be more than 360. So that would not be the smallest positive one. So that's how we find the smallest positive coterminal angle with the given angles. This will be useful when you're finding the values of trigonometric functions using the unit circle or the table later. Okay. So I say a degree is one way to measure an angle. There's another unit or another way to measure an angle, which is called the radian measure. Okay. So the definition of radian measure is the ratio of the arc length to the radius. So for example, we have an angle here. Let's say this is angle theta. Okay. Now, if we make a circle here, if we construct a circle connecting this, okay, then there's the radius of the circle, and this is the arc length, or the arc that is making the angle at the center. So this is the arc that makes the angle theta at the center of that circle. Now this angle theta is measured as the ratio of this arc length subtending that angle at the center divided by radius of that circle. So this ratio measure is the measure of that angle, and that's called the radian. Okay. Now, we know that the radius and the arc length, they are measured in some unit of length. So for example, centimeter or meter or something. So for example, if this is centimeter and this is centimeters, this is cancelled with each other. So there is no any unit for that angle. So usually when we write radian angle, sometimes we say, for example, 5 radians, or we just write 5. The angle is 5 means it is radian. So this is why it's very important that if it is degrees, we need to write that symbol degree. Okay, so if it is 5 degrees, we have to write 5 degrees like that. But if it is 5 radian, then we can either write 5 radian or we can just write 5. And we have to understand it. There is no unit. It is in radian measure, okay? Now we can convert an angle from degrees to radians and radians to degrees. So one way to look at it is when we make a complete revolution around a circle, we make 360 degrees. Okay, so when we have a complete rotation, we have 360 degrees. Now in radian, when we go around the circle and make a full complete revolution or complete rotation around the circle, we will make 2 pi radians. So that means 360 degrees is equal to 2 pi radians. Now that means we can convert from degrees to measures. So for example, what is 1 degree? If we divide by 360, we get 2 pi over 360, and that gives us pi over 180. So in order to convert from degrees to radian, we multiply by pi over 180. That's why. Okay. Now, if we take 2 pi equals 360 degrees, and if we divide by 2 pi on both sides, that means 1 radian equals 360 divided by 2 pi. Or if we reduce that fraction, we get 180 over pi. So to change from radians to degrees, we multiply by 180 degrees over pi. Okay, so that's how we can change an angle from degrees to radian and radians to degrees depending on what we want. Okay, so let's look at some examples of this conversion. So here we have angles in degrees and we want to change them in radians. So going from degrees to radian, we multiply by pi over 180 degrees. So 720 degrees equals 720 times pi over 180. And then if we reduce this fraction, so 720 divided by 180 is 4, so we get 4 pi. Now you can either write radians here, or you can just write 4 pi and write no unit. So if you don't write any unit, that means it is radians. Similarly, 60 degrees, we can change this to radian by multiplying this one by pi over 180. So this is 60 pi over 180, or if we reduce that fraction, we get pi over 3 because 60 goes 3 times and that many radians. So we can just leave as pi over 3. So negative 240 times, we have pi over 180. So 240 over 180, if you reduce that fraction, you get negative 4 over 3. So it's negative 4 pi over 3 radians. So that's how we convert from degrees to radians. Let's look at another example where we are converting from radians to degrees. So we have 4 pi. So we are going to multiply when you go from degrees to radians, we'll multiply by 180 over pi. Now here we can cancel out pi and pi. So 4 times 180 is 720. So this is 720 degrees. So make sure that you write the degrees, okay, that symbol. Now pi over 6 radian equals pi over 6 times 180 over pi. Now what happens here is pi and pi cancels out, so 180 divided by 6 is 30 degrees. Similarly, negative 2 pi over 3 times 180 over pi. Okay, so now we can cancel out pi and pi, and then 3 goes 60 times to 180, and that gives us negative 120 degrees. So this is how we convert from one unit to the other unit, or between degrees and radians. Okay. Now this very important concept here, reference angle. Reference angle means, so for example, we have an angle in the standard position, then its reference angle is the angle, okay, whose terminal side, the angle made by the terminal side and the horizontal axis. So for example, let's draw the coordinate plane here. So usually a horizontal axis means x-axis, and then the vertical axis is the y-axis. Okay, so for example, if I have an angle in the first quadrant, theta, Okay, so this is an acute angle. So for the angle in the first quadrant, the reference angle is the angle itself. So theta equals theta prime. So this is because that is the smallest, or that is the acute angle made by this terminal side with the horizontal axis or the x-axis. But if my angle is in the second quadrant, let's say my angle is right here in the second quadrant, okay? Now, in that case, let's say this is my angle theta. So that is not the acute angle with the horizontal axis. The acute angle with the horizontal axis is this angle right here. So this is the reference angle for theta. Okay. Now, how do we find the reference angle? It's very easy. If the angle is in the second quadrant, then we do 180 minus the angle gives us the reference angle. So 180 means the full straight angle minus this angle theta gives us this angle, which is the reference angle. Okay. Now, what happens if the angle is in the third quadrant? So let's look at that. Okay. So if the angle is in the third quadrant, so this is how we find the reference angle. Um, let's put that here. So let's say our angle is in the third quadrant right here. And then let's say this is the angle theta. Now the reference angle is the smallest, or the acute angle made with the horizontal axis. So it's not this angle because that's not the acute angle. So this is the acute angle, okay, which is the reference angle. Now in order to find the reference angle, if the angle is in the third quadrant, then what we do is we will subtract 180 from the angle because this is theta. This whole angle is theta now. So the reference angle equals theta minus 180 degree if it is in the third quadrant. Okay. Now if the angle is in the fourth quadrant right here, they said that is the angle theta. Now the reference angle is the angle made by this terminal side with the horizontal axis or the x-axis, this one. That's the reference angle. Now if your angle is in the fourth quadrant, to find the reference angle, what we do is we will do 360 minus the angle. So 360 means the full circle minus this angle will give us the remaining part, which is the reference angle. So reference angle is again very important when we are using the unit circle to find the value of trigonometric functions later. Now this one says find the reference angle for the given angles here. So for that, what we need to know is we need to know where is the angle in which quadrant. So let's go ahead and draw that here. So let's see. So 351 degrees. So this is 0 degrees. This is 90 degrees. Okay. This is 180 degrees. This is 270 degrees. And then back to 360 here. So now 351 is an angle in the fourth quadrant. So remember, in the fourth quadrant, to find the reference angle, we have to do 360 minus the angle. Okay. Now this one, 220, is an angle in the third quadrant right here. This is 220. Now, in order to find the reference angle for this angle in the third quadrant, we have to do theta prime equals theta minus 180 degrees. Now, where is pi over 4? Because that is in radian now. So in radian, this is 0 radian. This is pi over 2. 180 means pi. This is 3 pi over 2. And then this is 2 pi. Now, if you're not sure where is pi over 5 pi over 4, what you can do is you can just put it into the calculator. Okay, so if you put 5 pi over 4 in your calculator, then you will get 3.92, which means so pi is 3.147. So 3.9 is should be in the third quadrant, right? So yeah, it should be in the third quadrant because this is 4 point something. This is 3.147, and then so it should be in the third quadrant. So then we use the same formula that we have here. So let's go ahead and find that. So 220 in the third quadrant. So the reference angle is theta minus 180, or 220 minus 180 degrees, and that gives us 40 degrees. Now 351 is in the fourth quadrant. So the reference angle for that one, theta prime, is given by 360 minus 351 degrees, and that gives us 9 degrees. Now for this one, this is in the third quadrant, so we have to do theta prime equals 180 degree. If it's in degree, we do 180 degree, but it's in radian. So we have to do theta minus pi here. Okay, so theta is 5 pi over 4 minus pi gives us pi over 4. So that's how we find the reference angle, and this is very important when we start finding the values of the trigonometric functions. Okay. Now, another thing that we are going to look at is the length of the arc. So, for example, we have a circle, and now I know this for example, this is the center of this circle, and then I know the radius and the central angle. So, for example, this is theta, this is r, and if I'm interested in finding the arc length, so the length of the arc from here to here, let's denote that by s. And then if I want to find that, if I know the radius and theta, I can find s. Or if I know the theta and s, I can find the radius. Or if I know radius and the arc length, then I can find theta or the angle. So this comes from the definition of radian. Okay, so theta equals, we did that, theta equals s over r. That's the definition of radian. So it comes from there. Okay, this formula. So the arc length equals radius times the angle, but you have to be really careful here. The angle must be in radians. If the angle is in degree, we cannot put that into this formula. So before we put it into the formula, we have to change it to radians. Okay. So let's look at this example here. So it says find the length of an arc of a circle of radius 5 associated with an angle of 120 degrees. We know that S equals R times theta, but we have to make sure that theta is in radian. We have this in degrees. So our radius is 5 centimeters, and then the angle is 120 degrees, but we'll convert that into radians. So we multiply this one by pi over 180 degrees. So when we do that, so when we multiply 120 by pi over 180 degrees, so we'll get this equals, so if you reduce that fraction, we get 2 pi over 3. Okay. Now we have the radius, we have the angle, so the arc length, or the length of the arc, so length of the arc equals r times theta, or the radius is 5 times theta is 2 pi over 3, and then that equals 10 pi over 3 centimeters. Now if you want to change that to decimals, you can put it into the calculator, and then we'll get 10.47 centimeters. Okay, that is A. Let's look at B of that question. B says find the central angle. Now it's asking us to find the angle in degrees subtended by an arc length of 12 centimeters in a circle of radius 8 centimeters. So we are given r equals 8 centimeters. We are given the arc length s equals 12 centimeters. And then we are asked to find theta. So just from this formula, if you have to find theta, you divide by r on both sides. So you get angle, which is theta, equals s divided by r. And then if you put this into the formula, so 12 centimeter divided by 8 centimeter, and that gives us 3 over 2 if you reduce that fraction. Now this is in radians. Remember, always from that formula, when we use that formula, we put the angle in radians, and when we get an angle from there, we get the angle in radians. So this is in radian. Our question is asking us to find the angle in degrees. So what we do is we'll convert this into degrees, okay? So now theta equals 3 over 2 radians. So in order to convert to degrees, we have to multiply by 180 over pi. And then if you simplify this, we get 270 over pi degrees. Or if you change it to decimal, it's approximately 85.94 degrees. Now, another example that we are going to look here is the area of sector. So probably you know what sector means. So if you have a circle, okay, now if I have the center here, now if I take a piece of the circle, just like cutting a piece of pizza, okay, so if we take a piece like this, Now this is the sector. So this piece of the circle, this part of the circle that connects from the edge to the center, and then if we cut it this way, so this area is the sector, the part of the circle. Now the area of the circle, sector of a circle, we know the area of the whole circle is pi r squared. But to find the area of the sector, we have a formula which is 1/2 r squared times theta. Okay, so that is the formula that we are going to use to find the area of the sector if we know the angle. The angle is the central angle here. This is theta, this is r. So we know the radius. If we know the angle of the center, then we can find the area of the sector using this formula. Again, it's very important that the angle must be in radians. Always when you're using this formula, arc length formula, area of sector formula, your angle must be in radians. So if it's given in degrees, make sure you change that to radians. Let's look at an example. An irrigation pipe is 150-meter long. Find the area that can be irrigated after rotation of 210 degrees. So we have an irrigation pipe, and then we are rotating that. Okay, so it makes a circle. This is not a perfect circle. I didn't make a perfect circle, but yeah, we have a pipe. Okay, now we rotate this. Okay, and then when we rotate that through 210 degrees, okay, then it covers some area. So we are finding the area of this region that can be irrigated. Okay, so here basically this angle is 210 degrees and the length of the pipe is the radius, which is 150 meters. So now using the area of sector, we can find the area that can be irrigated. Okay, so if we do that, so let's erase this. If we do that, so area of this sector is given by 1 over 2 r squared times theta. So here radius is 150 meters. Now theta is 210 degrees. Again, remember when you're using this formula, your angle must be in radians. So we have to change this one into radians. So multiply by pi over 180 degrees. And that gives us 7 pi over 6 radians. Okay. Now let's put that into the formula. So it's 1/2 radius squared times the angle. And then if you put this into the calculator, the whole thing, you approximately get 41,233.4. And the unit for the area is square meter. Now let's look at the last thing. I think this is the last thing that we are going to look at in this video is the linear and angular velocity. So when we are talking about motion of an object, especially when we have a circular motion, like the earth is revolving around the sun, or we have some circular motion. So we have two different types of velocities or the speed, okay? So one is the linear speed, that's the distance covered per unit time, that's the linear speed. And then there's another speed that is the angle, okay, angle subtended or the angle made at the center of the circle per unit time. So the linear speed, which we are very familiar, linear speed is distance over time. And then so for example, let's draw this circle. So we have this center here, let's say. An object is at position A and it's moved along the circle to position B. Now we have this distance, let's say that is S. And then let's say this angle is theta, the radius is r. Now, the linear speed is just simply the distance traveled divided by time. That is the linear speed. Now, the angular speed is the central angle. So instead of distance, we'll check what angle does it make, okay? What angle does it subtend, or what angle does it displace through, okay? So that angle, so that's the angle divided by time gives us the angular velocity. So it's the rate of change of the angle at the center of the circle. The linear speed is the rate of change of the distance per unit time, okay? Now there's a relationship between linear speed and the angular speed, which is linear speed equals radius times the angular speed. And this symbol is called the omega. It's a Greek letter, okay? So now this is how we get this relationship. We know that the linear speed equals s over t, or the distance over time. Now when we're talking about the circular motion, the distance, this distance s is just the length of the arc. And we just have the formula that the length of the arc is given by radius times the central angle. We just have that formula. So if we replace that s with r times theta, then divided by t. Now what we can do is, now this part here, okay, so theta over t, that is the angular velocity or angular speed. Now if you replace theta over t by omega, then this gives us r times omega. So that's how we get this relationship here, okay. So the linear speed equals radius times the angular speed. And then the unit, you really have to be careful. The linear speed or linear velocity has the unit of anything measure the distance unit or per unit time. So like centimeter per minute or centimeter per second or miles per hour. So that's the linear speed. When it comes to the angular speed, it is the unit is radian per unit time. So 5 radians per hour or something like that. Okay, so you really have to be careful with that. Now let's look at this example. A satellite is revolving around the Earth in a circular orbit 1200 kilometer high. So let's say we have Earth. Let's say this is the Earth. And then there's a satellite revolving around the Earth. So let's say this is the orbit of that satellite. Okay. Now it says the height of the satellite from the Earth is 1200 kilometers. So this distance is 1200 kilometers. And then it can make one complete revolution every 90 minutes. What is the linear speed? And then what we have to consider is the radius of the Earth is 6400 kilometers. So my picture does not look accurate, but let's say this is the radius of the Earth, which is 6400 kilometers. Now, if you're talking about this satellite that is going around the Earth, let's say this is the satellite. So now we can forget about this blue circle. So for that satellite, the circle is the red circle, and then radius for that satellite is this distance from the center of this Earth, or that's the center for the big circle. So the radius is actually 1200 plus 6400 kilometers. So which is or equals, so if we add 1200 plus 6400, then we will get, so that is equal to, how much is that? 7, so 7600 kilometers. So that is the radius, okay? Now, the next thing that we need here is the angular velocity. So angular velocity is, so we really have to be careful here. It says it makes one complete revolution every 90 minutes. So in one revolution, the angle that we go through is 2 pi. Okay, so it goes through 2 pi. So remember the angular velocity is theta over time. So the angle that it goes through in 90 minutes is 2 pi divided by the time is 90 minutes, and that gives us pi over 45. This is radian per minute. Okay, so that is radian per minute. Now what we are asked to find is we are asked to find the linear speed. So v, or the linear speed, equals radius times omega, or the angular speed. So radius is 7600 times the omega is pi over 45. Okay, now approximately if we put this into the calculator, we get 531. So the linear speed is kilometer per minute. Now let's look at another example here. So a tire with a radius of 15 inches. So we have a tire. The radius of that tire is 15 inches. Is spinning 60 revolutions per minute. So that means the angular speed is 60 revolutions per minute. So one revolution is 2 pi. The angle made per revolution is 2 pi, but we have 60 revolutions here. So that means, okay, so the radius, so for A, radius equals 15 inches. Now the angular velocity is 60 revolutions per minute, or 60 revolutions means 60 times 2 pi, which is 120 pi. That is the angle per minute. Okay. Now the question is find the angular speed of the tire in radians per second. So we have to find per second, okay? It's given in per minute. We just have to convert that unit, okay? So 120 pi per minute. So if we change that to seconds, so it is 60. So that gives us 120 divided by 60 is 2, so 2 pi radian per second. So that is the angular speed in radian per second. So the part B is asking us to find the linear speed in inches per second. So we know the linear speed equals radius times the angular speed. Radius is 15 times angular speed is 2 pi. So that gives us 30 pi, and it is inches per second because this is already in second. Or if you put it into the calculator, you'll get 100.53 inches per second. Okay, I think that's all for this video. In the next video, we'll start defining the trigonometric functions, and then we'll look at more about the trigonometric functions. So this is the initial introduction to angles, how we measure angles, linear speed, angular speed, area of sector, and the arc length. So the basic information. Now moving on to the next video, we'll start looking at the trigonometric functions.